Well, the probability that x bar is less than 19.97, again, we're going to look at probability on a normal curve, which means we're using z-scores again. So we convert x bar into a z-score, which we already did. So the probability that x bar is less than 19.97 equals the probability that z is less than negative 1.06. And that is where we use our tables and look up negative 1.06. Okay, so here's 0.6, and the negative 1.0 is down here. So that gives us 0.1446 for the area to the left of z equals negative 1.06. So there's our probability right there. So the area from our 19.97 to its left is 0.1446, or 14.46%. Okay, so although 19.97 is less than 20, our results from part C and D show us that 19.97 is not significantly less than 20, okay, or not statistically significantly less than 20. Here, the sample we took, resulting in a sample mean of 19.97 ounces, is fairly likely to occur if mu equals 20 ounces. Therefore, we cannot reject the original assumption. Okay, and the original assumption was that mu equals 20. Okay, so again, it's really important to understand what's happening here. We took a sample, and that sample mean ended up not being far enough away from the assumed mean of 20 to say that assumed mean of 20 made no sense. Okay, so 19.97 is close enough to 20 to say that we cannot reject that original assumption that mu equals 20. Okay, so 3A, okay, looking at that one. Okay, now we look at the second case that we took, or the second sample that we took of the 50 bottles, and we got 19.90 ounces for the sample mean. Where is this value located in relation to our assumed value mu equals 20? So again, we're going to look at the z-score for x bar equals 19.90. So that z-score, if you do x bar minus mu sub x bar divided by sigma over square root of n, okay, that gives you a z-score of negative 3.53. Well, 19.90 for the x bar value, when you look on the axes up here, 19.90 is going to be out to the left here. Okay, because 19.91 is here. So 19.90 is going to be to the left of that. Well, that's more than 3 standard deviations below the mean. More specifically, 3.53 standard deviations below the mean. Now that is a very small z-score, okay, or you could say a large negative z-score because we're going farther out to the left here. Okay, so that z-score to the left of the mean tells us that it appears that assuming that mu equals 20 was not a good assumption to make. Because if the mean really were 20 of the population, then to get a sample mean of 19.90, if you took 50 bottles, that would be unusual to have that happen. Well, how unusual would it be? Find the probability. So let's in part B, find the probability that x bar is less than 19.90. So what is that probability? That x bar is less than 19.90. It equals the probability that z is less than negative 3.53. And in your table of values, again, different tables give you some different things here, but negative 3.53 actually doesn't even show up on this one because ours only goes up to negative 3.49. And notice we get 0.002 there. Okay, so it's approximately 0 or 0.0001. Okay, basically, it's a very small probability. Okay, again, there is some leeway on that one because different tables show you different amounts. They go to different values. Okay, but a very small probability. Okay, so nonetheless, in this case, 19.90 is less than 20. Okay, there's no disputing that. But 19.97 was also less than 20. But now we see the results show us that 19.90 is significantly or statistically significantly less than 20. The sample mean of 19.9 ounces is unlikely to occur if our assumption that mu equals 20 ounces were really true. So therefore, we reject the original assumption that mu equals 20, allowing us to support the alternative notion, or the alternative hypothesis, that mu is less than 20. Okay, so again, what happened here was the sample that we took ended up being an unusual result, or an extreme result, if the mean really were 20 of the population. Okay, so therefore, our assumption that the machine was calibrated correctly in dispensing 20 ounces was probably a bad assumption to make. So we reject that original assumption that mu equals 20. Now remember that original assumption was a null hypothesis, that mu equals 20, allowing us to support the alternative notion that mu is less than 20. Okay, now the next thing we get into in the next video will be kind of questioning the idea of, all right, well, how do you know whether it's significant or statistically significant or not statistically significant? Okay, so where do you draw the line at? Okay, so that is a more formal form of hypothesis testing. Okay, which is what we get into next.